Hello, everyone. Hello, everyone in the room. Hello, everybody on Zoom. Today, we are going to be covering networking. Well, Minh is going to be running the networking meeting. Real quick announcements. Hello. Shibboleth, we still need people who would want to maintain our Shibboleth authentication. It's how you sign into our server as a UAUC member. If you're interested in that, it's a cool thing. You can put it on your resume. You know, it could help. And also it really helps us and we'd really appreciate it. Also, website, we need people who know web, and that's not a lot of people at this school because we're a systems school. So if you know how to do web dev and you would be interested in helping us out, that would be a huge help. You can also put it on your resume. That takes a lot of the burden off of us who are doing it anyway. So yeah, if you want to do that. Also, merch form still out. We're still trying to gauge interest on merch before we actually go live with that. SIGPwny.com/merch. It might still be broken if someone wants to let me know and go submit a pull request to our website. And then same again, at some point this semester, we're going to try and do a spray paint social where we go to the alleyway and do spray paint. Still broken. Great. Can you submit a pull request and fix it?
No.
Can someone who knows like webby things submit a pull request?
The link's on the CTFD meeting.
The link is on, yeah.
Merch.
Okay, the link is on the merch challenge form, so go fill it out. Okay, cool. I skipped a lot of slides. All right, take it away.
All right, yeah, that's the meeting flag. Please do not throw sausage pizza away. Want to know why that's a flag? It is the acronym. It's a mnemonic to memorize the acronym for the OSI model. So physical, data link, networking, transport, session, presentation, and application. And of course, it's ACP. All right. Oh, what the? Okay. So what is networking? So networking is just a way for computers to send information from one computer to another. One common example that we all know is the internet, but there are also smaller networks that aren't connected to the internet. For example, you can have a network of ATMs that communicate information between each other. Now, in order for computers to communicate with each other, they need to speak the same language, or at least some sort of standard. So that's why we have a lot of protocols that describe networking. And there are a lot of different companies that build different products. So you'll often see different protocols built for different proprietary products. And as a result, there are a lot of protocols and a lot of acronyms. So hopefully that's not too overwhelming when you see a bunch of acronyms. And the first acronym we'll go over is the OSI model. So the OSI model is the Open Systems Interconnection Model. It basically breaks down all of networking into 7 different layers. And each layer is designed to be abstract from a different layer. So for example, layer 7, it doesn't need to worry how layers 1 to 6 work in order for it to do its thing. So the OSI model, yeah. OSI model kind of looks like this. So we have 7 layers, and usually it's visualized so that way you start with the bottom, the lower level, the lower layer to the higher layer. And it goes from kind of like being more physical, eventually reaching to more software side of networking. So the bottom layer, which is layer 1, is physical. So this just represents like Ethernet cables, fiber optic cables, basically medium for binary data to travel through. The second layer is the data link layer, which describes how data is transferred between 2 specific hosts. And then the network layer describes how you route information between multiple hosts. So let's say I'm on my network at home and I want to communicate with a server in a far off country. the IP network, and also border gateway protocol. And there's a bunch of different layer 3 protocols that will determine how your data will get to that server. Layer 4 is the transport layer, which basically describes how your data flows. So there's TCP, UDP, which are the two most common types of transport protocols. And then the top 3 layers, these are all the same color because they're usually kind of bundled together. These are your software implementations of networking. So as a programmer or a computer scientist, this is probably where you're going to spend most of your time building software and applications that deal with networking. So layer 5 is sessions. It deals with how you begin a connection with the server. Presentation describes how you encode or encrypt data. And then layer 7 is the actual application data that your host uses to do its stuff. All right.
Okay. All right.
So real quickly, I'm going to talk about TCP versus UDP, which we briefly mentioned. And as you remember, it's layer 4 of the OSI model. So imagine you want to call someone. A TCP conversation would be something similar to a normal conversation. So you say, hello, I'm A, and person B will respond, hi A, it's B, and hello A will start telling B what data it wants to send it. And UDP would be a voicemail. So A would just send B its data, and there's no guarantee that B received the data from A. It's basically just a quick way to send information, and you don't need to necessarily have a connection between the two.
I'd make a UDP joke, but you guys might not get it.
And now from a technical standpoint, so it's a very similar idea. So TCP uses what we call a 3-way handshake. You send a synchronized packet or SYN, and then host B will send back a SYN acknowledged packet, and then A will establish a connection to B by sending an acknowledged packet. And then TCP ensures reliable delivery of data, and it's also more secure than UDP because you have to establish a connection before you're able to actually send data. And UDP is just constantly streaming the data. It's useful for like low latency games or video streaming because you want to like view the information faster. But there's no guarantee that you'll receive the data. So that's why sometimes you'll see videos buffering or loading slow. Because it might just be missing some of the packets that needs to reconstruct the video. All right, so now we'll talk about network attacks on the OSI model. So the first is a SYN flood attack. And this kind of abuses the 3-way handshake that we talked about earlier. So an attacker will send a SYN packet to the server. Now the server will have to respond with the SYN act. And then the attacker will receive that. And then the attacker normally would send an ACK packet back to initiate the connection. However, the attacker can choose not to send this information to the packet. And then the server is just waiting for that ACK packet because it can't start the connection without it. And eventually it's just waiting and waiting and waiting until it times out, which is normal. Sometimes packets get missing, so it just terminates the connection. However, if an attacker sends a lot of SYN packets, then what the server ends up doing is it has to keep waiting on a bunch of network connections until eventually it just starts timing out connections. And so what can eventually end up happening is legitimate traffic can't connect to the server because it's too busy dealing with the existing connections that haven't timed out yet. So that's a SYN flood attack. It's an example of a DDoS attack.
Real quick, what does DDoS stand, or like what is a
DDoS,
DOS and then what is a DDoS?
DOS is a denial of service attack, and a DDoS is a distributed denial of service attack. So that's when you have multiple devices attacking a single host. and basically overwhelming that server until it can't function anymore.
The first defense that people came up with against the DOS, which is basically, hey, you can't use our thing anymore, was just block the IP, like don't even deal with any of the packets coming from that IP. And the response was to invent the DDoS, which was let's hit a server from like every possible location. So yeah, cool. So a little bit lower than this is ARP cache poisoning. And ARP cache poisoning is basically ARP is address resolution protocol, and it's a way to take your IP address that you're assigned from a network, so like a Wi-Fi or something like that, and say associate it with your hardware address, which is the address that's like baked into your computer. Like it's assigned to your computer at manufacturing point. So how that works is routers and central spaces will send out a big broadcast that says, hey, who is 1.2.3.4? And the whole idea behind an ARP cache poisoning is to go and respond before a legitimate host and say, oh, I'm 1.2.3.4 and my MAC address is AABB, blah, 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 blah. And then the valid host responds later, and it doesn't matter. It's just going to take first come, first serve. So it sets 1.2.3.4 to ABCDEF. And then any traffic meant for 1.2.3.4 is going to go to you instead of the legitimate host. So that's another common attack that happens lower than TCP and that stuff.
And then another attack you can have is a man-in-the-middle attack. Basically, it's exactly what it sounds like. You have an entity sitting between two parties that are sending data to each other. And then you can, usually without them knowing, and then the attacker can read data or modify the data, manipulate it, and resend that data to make it look like, let's say, A was sending hi to B, and the man in the middle was in the middle, and it changed that hi to like a goodbye. So that's an example of how a man in the middle would, an active man in the middle attack would be. A passive man in the middle attack is just reading the data and kind of stealing information. Your ISP or any other devices that your network traffic goes through to get to its destination can also be considered a man in the middle, which is why we have encryption and certificates today to prevent that sort of things from happening. So here's like a more visualized flow of a man in the middle attack. So you have this normal connection between computer A and server B, but with the man in the middle attack, the man in the middle pretends that it inserts itself between the connection between A and B. A is thinking it's talking to B, but A is actually talking to the man in the middle. And then the man in the middle will then forward the information from A to B. And then B will respond back to the man in the middle, and then the man in the middle will forward its response back to A. So that's kind of what man in the middle does. And as I said earlier, to break this, you would have a certificate that A would trust. So the server will assign a certificate to a certificate authority. A will download that certificate, and it will verify whether or not the host is communicating with is actually B. Cool. Next slide. So these are some other attacks kind of on the OSI model. So as you can see, ARP poisoning, which Thomas talked about, is considered both layers 2 and layers 3. So another important concept about the OSI model is that not all your protocols have to be limited to a single layer. You can have a protocol work on multiple layers. So ARP poisoning would be considered both layer 3 for IP addresses and layer 2 for MAC addresses. And then application layer is basically just like attacking a website or performing a buffer overflow. That's just what it's on. And presentation is not really crypto, but presentation is usually dealing with like TLS, HTTPS encryption. Yeah. And then layer 1 physical, one example would be like destroying physical cables to take down a network. So these are just kind of these are just like, there's a lot more examples, but these are just a few that can be represented on OSI model.
Does everyone still see the slides? I know that sometimes like on Zoom, because sometimes web browsers are weird and I just got a notification on another one. I just want to make sure we're all good. Just thumbs up in chat or something. Sorry, y'all. Okay, we're good. Cool.
Okay, so now we're going to introduce a tool called Wireshark, which can visualize all the network traffic between your device and even just post from on another node. So you'll be able to see information being transferred across your network in packets. And you can use Wireshark for a bunch of different things, like as I mentioned, finding information. You also use it for network forensics. In CTFs, you can use them to steal another team's exploits and then run them yourself, which is pretty unique. Next slide.
Another cool thing about Wireshark is that if your system allows for it, you can do something called monitor mode, which basically just means let's allow the network card to look at every single packet that exists. So not just like things that are meant for you or things that are meant for the network, but like everything that's going through the air that happens to hit your card will show up in monitor mode. It's really cool to look at, see if your computers are capable of doing it. Anyway, go ahead, sorry.
So this is an example of what the packet capture in Wireshark looks like. So at first it looks like a lot is happening, which it is, but Thomas, next slide. It's just really 3 different windows. So covered by that by the camera is packet list. So in red, all the packets that are in the packet capture are listed there. You can scroll through them and quickly show you the timestamps, where the packet's going, where it came from, and what protocols it's using. Then when you click on a packet, you'll be able to view its details in this main window, which is packet details. It basically parses all the data from the packet bytes into like a prettier format for you to understand data from. And the packet bytes window is like the raw physical binary that gets sent through the network. So this is just kind of the general layout of Wireshark, and you would navigate mainly through the top part and read the data in the bottom parts. So what makes Wireshark really powerful is use of filters, because when you're dealing with a packet capture, you won't have a lot of different data coming around in your network. So sometimes you just want to filter the traffic so that way you can find only one thing. So you would be able to add a display filter, and it will filter your traffic based on the parameters you put in. So some examples in the next slides. So here, you can just type in HTTP in the filter, and it'll show you only HTTP traffic. So then you can see like what a user was requesting from a website and what content is returned. Another example, another example is filtering for an IP address. So if you're like investigating a single machine, what you can do is you use the IP protocol, and then you give it a parameter of address. And you set it equal to the address you want, and it will show you only packets that deal with that specific IP address. And there are a lot of more filters. You can combine filters together to create a more to get something that you want more closely to your objectives. Yeah. And similar to kind of what we're talking about, you're going to have a lot of conversations on your network, some of which are just completely random and not all relevant. So what you can do is, if you find a packet that's interesting to you, you can right-click it and then follow the string for that packet. So it will put that in context, that packet in the context of the previous packets, and it will generate a conversation that involves that packet. So think of like a room where a lot of people are talking to each other, and you wanted to focus on a conversation between two people. This is essentially what that's doing. And it's also, this right click method is just basically an easier way of using a filter to filter a string by a number. Yeah. Then Wireshark is also available for scripting and in the command line interface. So TCP dump is what you would use to actually capture packets. T-shark is what you use to extract the data if you want to view it in a more programmed manner. Or let's say you're given a Wireshark capture, and all the data is separated between a bunch of packets. And there's no real easy way to do that, to export all that data in Wireshark. So what you can do is use T-shark to extract that data in a very text-like format and parse it so that way you can combine it to do whatever you need to do. Then PyShark is just T-shark, except it's a Python wrapper and you can use it in Python scripts. And then just a brief mention, there's also Burst Suite, which is more of a tool used for web app exploitation. But I thought I'd mention it because it's kind of similar to Wireshark in a sense, except that it's only for web application traffic, so HTTP, HTTPS, WebSockets, and so on. Basically, what it does is it creates a man in the middle for your own web traffic, and you're like, why would I want to do that? That sounds evil. Well, it is kind of evil because you're basically looking at the request that you send to a server, and then try to modify it to try to break the server. It's a big part of web app exploitation. There's no challenges. We don't have any challenges.
They're hard to make. They're so hard to make. We're working on it. The two big suites of challenges I want to work on are like actual networking, live networking challenges, and then like some more like similar stuff.
Yeah, so Burst Suite would be more like for the network side of web hacking.
Yeah.
So challenges that should be on the CTFD. We have layers 1 through 7, except for 5 because I didn't make one for that. They're basically really easy, super approachable to basically learn Wireshark. We have 2 challenges from the previous forensics meeting, so file transfer and live stream fail. We have a new hard challenge called pool, and we have an extremely difficult challenge called 2v2t, which I made for UCTF 2021. Basically, it's like a mind test game, and you're trying to reverse it to reverse like a basically briefer.
It's a really cool. That's a really cool challenge that he made. If you can't solve it, there are write-ups that exist, but please don't submit the flag if you get the write-ups from the event. All right, thank you so much, Minh. Everyone give Minh a round of applause. Real quick, next meetings, the weekend seminar is because unless this is the last chance, does anyone want to run a meeting that is not wireless networking this Sunday? And we are running wireless networking this Sunday. So that is networking, but over wireless. So what are the unique challenges that exist there? And how can it be exploited? I'm pretty sure there's a video up from last year on the exact same topic. So we're going to be covering it this time. It'll just be in person. And then next Thursday is going to be Windows environments. So we're going to be talking about hell. I mean Windows. So that's everything from Active Directory to domain controllers to kind of the first steps for a more realistic like environment. So that's like actual pen testing, actually going into like more realistic corporate environments and figuring out how to attack them. So that's, AD, domain controllers, NTLM, SMB, all that crazy crap. So that is the meeting. Does anyone have any questions about networking that you think would be valuable before we go to challenges? No? All right. In that case, I'm going to end the recording. Have a good one.